So the last few videos, I don't know, I've been like real low motivation to actually work on the operating system, and I thought I'd play around with some Git stuff to try and find a bug, basically. And you can check out the other videos if you're interested, but the idea was that I had a kind of, well, it wasn't a commit at that point, but it was basically a bunch of stuff in my stash, staging area of the Git, and there was a bug in it, so we can see, run this at, that's like an even worse case. I thought it would be, oh no, because I reverted the one that might have been breaking, so I feel like, I don't know, check out, yeah, just that one. And that's, yeah, that, and now we run that. So this is kind of where we were looking, and like, it kind of doesn't really work. So like, input's not happening, but it's like still writing it. And so there's a bug somewhere with the, I was working on fork and pipe to basically spawn a new process. That's what you would call it. I think it's called task. My current code, but that's right. Yeah, so you kind of spawn a new process, and then the pipe is kind of setting up so the file streams still kind of work. Clearly, they don't. And so the gist was that if we, just get check out main, because I purposely didn't actually do anything. We'll see that it works here, but this is before we have a fork or pipe. Yeah, that's fine. Well, there's a fix there because I was going to fix it and have a pipe. So, I guess the last few videos I've been trying to, that should really be on, yeah, there. I've been trying to do like a thing, basically spanning it out. So I committed up the broken stuff and made that. And I had like a set of steps I was following, which is like there, yeah. Basically like a set of steps that I would do to kind of run through to work out whereabouts in the commit it is broken. Because like if we look at this, there's like a bunch of code. In fact, if we look at our glog again, we should have like 59 hunks in the staging area of the Git. Basically, when I the gist was I was working for a couple of months without committing because it wasn't finished, I guess. Because I tend to kind of write all the code until it's in the working state that I want it, and then I would like break it up into commits there. And in this case, I hadn't got it working, and so this video will actually be looking at the debugging aspect of that, because I basically ran through and tried to get it to work out where it was based on git bisect, and you'll see that, if you're real observant with my flickering back and forth, you'll see that these kind of go up in order, but now like 21's kind of there for some reason, and then like we have 30, and like what I was doing was basically reordering the commits so the bisect would work, because what I was trying to do was basically run a bisect. I might just check out back to head, and I had a little bisect script that basically says head is bad, and that C17, which should be, it's just gone out. This one here where we like reverted the broken commit, so that one was bad. It's basically the same as what is on main with a couple of things I haven't pushed, but that I was working on. And I also created a bicep run. Yeah, I created like a bicep script that basically builds it. If it can't build, we'll say 125, which is the error code that bicep will do to basically skip that. Now, what I was finding was it was failing to build pretty much every commit because some of the every commit out of this whole list. So it was basically failing on all these commits, and what I did to fix that was basically work out which commits depended on each other and reordered it so they went in there. And so now when we do this, now if we do that, it will basically skip all the builds that are failing. But with the reordered, we should either now get a good or a bad state when we run it. So we can say this is good, and we'll ask this is good, and here we can say that's also good. And here we I don't know, this looks bad. It's not the bad that we saw in the final one, but that's because that had some commits that were kind of breaking it. So we'll say it's bad, and we'll say this is also bad, and we'll say this 16 is the one that we do. And if I go to bicep reset, and in fact, check out that. If we look at my working branch here, that was where I started the bicep from, this second entry, and my last one was reverting that broken commit. And so that is why when we go run, it's kind of like in that weird broken state that it's broken in a different way, and you'll see it's actually doing panic, and the early write does that. So what I kind of decided was, hey, this was an experiment to see if I could create some sort of a tool that can magically show me where the broken commit is inside of my big status, and I decided no, it is not, because it kind of turns into a combinatorics problem that we need to work out which order to have all these commits in before running the bicep. And I guess here we've only got 60 commits ish. So theoretically I could put all these 60 commits in every different possible order. But if I did that, I'd want to change this script to at the moment it's spinning it up and asking me if it's good or bad, and I don't really want to sit there and be like, yep, that one's good, that one's bad, that one's good, that one's bad, for all combinations of those 60 commits, then running bisect on top of those. So I basically have to do it 5 times per combination, and combinations kind of expand quite largely, factorial, I believe. There's a formula for the number, but I can't remember it off the top of my head because I haven't done those types of things in a while. I used to do programming contests and it was right there on the tip, but not so much anymore. So what I think I'll do in this episode is go back to main, and we can run this and we can see it is broken. No, it's good. But we want kind of to get this commit here. So 9.1 BBC get cherry pick 9.1 BBC. Really. I will believe that. So we'll delete that. No, I didn't. so I'll cherry pick that, and so now if we run it will be broken. And this is in a state that we can probably do some debugging to work out how to fix it. And yeah, so if we kind of look at what we were doing, we could try and make this a bit easier to like split up the commit in a better way, but what I think will be the best is to actually just kind of step through and debugging and kind of see where things start looking wrong, and we'll see. Yeah, in this term new, I actually have like some debugging. No, it wasn't there. It was somewhere. Sorry, this is probably like gonna look real weird. Yeah, here in this is in fork. We have some debugging stack traces. So I was trying to do some stuff to work out how to fix it, and yeah, potentially coming back kind of fresh. Like I haven't actually worked on this in a while, and this might be either good or bad. That I have had some time away, that I can maybe see things differently and be like, that's where it is. So it might be real quick and I'll figure it out real quick, or it might be that we spend like an hour debugging and don't get anywhere. But we'll see how it goes. So yeah, I'll see what happens. So I think what I'll do is we'll go into debug and we'll split this out into there. And I'll break main because it's pretty early on where it kind of does it. And we'll kind of step through until we find somewhere that doesn't do what it's expecting. Those are kind of like test things, and this is like kind of a good test because it's testing the scheduler in a way that it was before, and we'll see it kind of does the right thing. So what it's doing is creating two tasks and counting down from 10 in each of them, but it's doing it in a cooperative sense. Yeah, like each task, once it prints one, it'll be like, hey buddy, you try the next one. And once they both finish, they finish. But these next bits, we're kind of like setting up a bunch of stuff to set up the streams, which that is a bit interesting because it's not quite doing what we want. And we can see there, like, that fork kind of changed everything. What we can see here is if EAX, that is 3 at the moment, and so fork is meant to return like the process ID. If it is the parent, yeah, so this is the parent process returning that, and so we're not going to jump to the child. We're just going to call schedule because what the child was meant to be doing, we can see there it calls term new. So I'd say the problem is either in term new or in that setting up of the setting up of this ring buffer for kind of getting things working, which that is a tricky one because it's kind of hard to know exactly where the problem is. What I might do is kind of go through the code and kind of rubber duck it to the screen to see what I think it's meant to be doing. So how we have the strings is we have like a stream object, and it's got an object that it like calls stuff on. So this ECX, which is the ring buffer here, and the stream has like a few different methods it can call. So putc will call that ring buffer. So basically, whenever you print something to the stream, it should put it in this ring buffer that we create and get that. And whenever we ungetC, we like put it back on the ring buffer, which yeah, it's kind of weird because the getC gets it from the keyboard. And we also set up like a term iOS object. So like when we've got a term iOS object, if we I might open up that and go over here and look at this live term iOS just to kind of see what this is doing. So term iOS has kind of a default that it checks for like a bunch of stuff, like whether it's buffering. In fact, like the code's not really that great for it. But how that kind of gets called is in source lib unisted, and I think on the right syscall. Well, it's not really a syscall, but it is in Linux land, I guess, or most Unix is. What it does here is it sees whether we've got this term iOS object, and if we do, we'll call the term iOS putc before we kind of do the write. And the reason for that is so what are we doing? So here ECX is going to be kind of the function that we're going to call. So down here, we're calling it ECX, and we like vision pop it beforehand so it stays the same. So by default, it's just going to be the putc, which will be this ring buffer putc. But if we have a term iOS object, which we do in this case, we'll call the term iOS putc. So if we look at that, that's kind of doing this, and it's it'll check whether we have canonical mode, and if we do, then it just goes to putc, and putc is like all the way down here, and what it will do, it'll get the stream, it'll get the object, and it'll get the correct putc, so there'll be this ring buffer, and it'll just call that. And it's got a little to-do to wait for the minimum. I don't think we need to care about that. And then it will also check whether we have the echo flag. And if we've got the echo flag, then we should call putc on the stream that is the term iOS echo stream, which should be this argument here, which is the EAX, which is the current standard in that. I wonder if that is our bug, maybe. That could be some issue, because like if we kind of go back to what it was looking, if we run that, it's so it's kind of echoing. It's doing some weird stuff on the input, but it echoes out, but it echoes out to I didn't want to do that, grabbed it. It echoes out, and the echo stream is this black background, which is actually just it's like irrelevant of the green terminal on top. One of the reasons why I made it like a weird green color, can be any color, but I just want it not black so I can see when it's writing to the underlying, I think it's like kernel early write. We can look it up. Let's finish that drink. So that kind of raises a flag. So what I might do is go back here and which I guess kind of makes sense because well, no, it doesn't really make sense because we're not really attached to a terminal here, so we probably don't want to actually have this at all. So what I might do is kind of just comment that out, see what happens, and we try and do like a TC get and so that will be happening later on. So it does kind of read all the thing, but yeah, so somewhere in this term new, where am I? Term new, yeah, so what I might do is go to the source lib term and look at what term new does. So here we've got some lovely commented out code, which who knows, might be doing the right thing, who knows, it might not. Yeah, so we got a bit of a comment here. Comments are good for when you come back after months of not looking at things. So the term currently has the standard and all the streams set up from the parent, which makes sense. So the current the current standard in should be the it should be just like the PS2 keyboard coming in, and we kind of want to send that from the kernel. Like it's going to be weird because we're going to have a window manager at some point, but they'll kind of go above this, and the term won't need to worry about that. All the term needs to know is I am now a terminal, so I should get all the input from that standard in stream, and basically that's now my new standard input. And like you would want to set up a term iOS for that, so it does the buffering, but it does the that doesn't do it. And you'd want it to echo to the new stream that you create, which is part of the term. So if we kind of, I might go here and close that, just to see what is happening here a bit better. I suppose I didn't really do much because it's just a large font. So what we're doing here, using a pipe for standard out and subtask. So standard out is currently just the terminal standard out. So this potentially is also wrong, because here, what are we doing? Where do we actually use that? Right, well, so we do that there, and we get file stream from ESI. Yeah, this doesn't seem right to me. In fact, this to-do might be... yeah. Because we want the terminal to have, like, potentially... yeah, I might let's do like a... I don't know, like, just a weird... so we have like kernel std in, and we kind of want that to go to this term std in. Kind of just the term should be like reading it, which there is a function that does it. This term process input, and that's doing some tc get attrs, which this. Yeah, the standard in shouldn't be there at the time. Yeah, what I might do is, it's like, we don't have like great debugging. Yeah, maybe I'll go and debug and I'll break on term new and I'll also break on term process input, and we'll display std want to see this. So if we get all that and do that again. So this is currently what standard in is, and if we skip to that, it's still the same. In fact, it's already complained about the TC gear there. So I think we don't really. Oh yeah, this to do. It's not setting up standard out at all. That's probably the problem. That yeah, we like. Not actually setting up standard out. And what are we trying to do here? But yeah, so what I was wanting it to do, basically, the terminal object will kind of read from that into its standard input, and then term prop will kind of have that, and it will write to its term std out, which will be the terminal, but it will also write to an std error, which is currently the just kernel one. We'll just do a 2 there. I don't know, I'm like making up what these errors mean at the same time. So yeah, that standard out doesn't exist, and that is kind of what we were seeing with the behavior that yeah, it's just not there. And I wonder what this is doing. This is kind of like making a standard output. Yeah. So we'll just see what we do. So we do a pipe, and what a pipe should do is create that one. It should create basically 2 streams, or 2 file descriptors that we can kind of write to. And the idea is that I'm going to do this pipe so we can kind of get a pipe. And basically, when you write to the first one, you can read from the So the first one you read from, and the second one you write to. So yeah, when you write to the second one, you can read it from the first one. I wonder if I have that order right actually, but that's alright. So we do this pipe, and we do all this like term OS. It's kind of annoying. And here we are getting that's just my one. No manual page for that. Yeah, so here we are getting the first one. So comments read end was the first. Yeah, read end, and this should be the right end. So what are we doing with the read end? We're setting the term iOS object on the read end to have a term iOS that writes the kernel standard out, which that doesn't seem right. Which yeah, we got this to do. This to do is and the right end we get that, and we set the term iOS on the right end to be ECX, which ECX is all the way up here when we get EX, and so that will be just that same term iOS. Right, so we're basically sending the same term iOS object on both the read and the write, which kind of makes sense conceptually. This is going to be like the standard in of this terminal object. Yeah. Then we fork. And if we're the parent, like potentially, yeah, I wonder whether the child kind of needs to wait until the parent does all this stuff. But yeah, if we're the parent, what we're doing is we're closing the read end, of pipe. Let's do that. Of pipe and of pipe and of pipe. Tab there. Right, so we close the read end of the pipe because nothing's going to be reading from it, I guess. But the right end of the pipe, we duplicate it to, and this dupe to, we take the old and we set the new. So we're basically moving the file descriptor to be standard out. So the right end will be standard out of the parent process. So at this point, std in should be curl std in is to and std out should be our pipe right end. Yeah, it kind of makes sense. So yeah, that term process input. The term process input should be getting information about the term OS object, making sure it's like in raw mode, so everything comes in streaming at once, which I guess we could do by just not having. Well, I guess if that fails, it just goes to return, and that's not quite what we want. We just want to go to loop maybe if that fails. To do should this jump to loop as it means that the screen doesn't. Why is it fine? It wants it no iOS is the same. Yeah, that sounds good. We can maybe change that later. If we run into issues, maybe we should print an error if this is catchy. Pardon me. Right, so we set it to raw mode, so that way whenever we do a read key, and so if we are reading in a key, that's basically like the global hotkeys. If we push I think we've set it up for Alt plus Alt down, will resize the terminal, and in fact we can we'll just go to here. Go back to there. Yeah, so here we can see. Not sure what that comment is meant to be. Escape 13A. We just do yeah, so we like do a bunch of stuff to work out whether something, like whether all the modifiers are down. That could probably get like refactored out at some point. But yeah, then we see whether it's up, down, left or right with an alt key attached, and if it is, then we just do the term move, and like who knows, that might actually work. Well, it's like full size. If we like .strc, don't do that, because it seems to be running that stuff. Yeah, so if we do that, that's kind of interesting. It's like run. Yeah, I don't know. I might keep that without the resize just so we can see that background. But yeah, verse. Right, we like jump from file we were in. Yeah, so if we. So that's what that will do, like handle all the hotkeys for like moving stuff up, and it's not working at the moment, but that's right. But if it basically doesn't handle that, EAX should still be the key that was pushed down, which might be a hotkey. So basically if the hotkey wasn't handled, it'll pass it downstream, and it will just write to whatever standard out is. Yeah, so I think that kind of makes sense. So it'll be coming from standard in the keyboard, and it'll be writing to the right end of the pipe. And in the child, what we are doing is right end, and this is the read end. So we should be doing the opposite. Yeah, kind of the opposite way that what we call the opposite of the parent process. So it will be setting the read end of the pipe to be the standard end of the child process. So like whatever this term new got called with the start function, and then it'll just call that start function, which should be well, we can confirm that. Yeah, that's alright. Where's the comments? It should be that shell main. So source shell main. So at this point, I might just go here and write so stdin should be read end of pipe. Std out should be kernel std out, which it should what we should be doing is setting up our own std out, but keep the std error the same. So like if something writes to std error, it'll, potentially we should just have both as both. Yeah, so what do we need to do? We need to set up an std out, and we need to link the std in term iOS to that std out, and that potentially should be done up here, which is kind of what was done there. But we don't really want to do that in the parent process, because we want the parent to still see the right end of the pipe, so that the kernel std comes in and it will write to that right end of the pipe. Yeah, that makes sense. So potentially just copy this commented code down later. And EBX is our terminal, yeah, and term.c is kind of what we want. And then we yeah, so that's EAX is like stream, that doesn't seem right. Yeah. This should be FB, not a stream. So that should be like to call the opposite of file stream. Source file stream. It is stdio source stdio. Yeah, sure, that was his comments. Std file stream. File stream. It's like something else that's not in here. Source unis. No, source scheduler. No. It's like the one I probably should remember because it's like actually in POSIX, and I would have used it like before doing all of this. Don't know why. What if I do like in scheduler we should in unisted. I should jump better there. Say in right we will file stream on the file descriptor. Yeah, so in so in put C say here we should file node, that's the one I want. So file node takes the stream and gets the file descriptor. Look at this going. What did I want to go back to? I want to go back to term. Yeah, call file no. EAX. So EAX should be the stream, but then once we call file no, that should be the file descriptor, and then we'll duplicate it to standard out, and then we'll pop back the original EAX, which should be the stream again, and then close also takes the file descriptor. Yeah. And yeah, potentially what we want to do is not do this dupe and close until we're we might set up the standard out here and then use that as this term OS new. Yep. Rather than just the current standard out, because that's just like the terminal standard out, and we don't really care about that because we're trying to draw some terminal stuff. Yeah, that kind of makes sense. So what I might do is give This, like, maybe I'll get an EDI, push EDI. EDI kind of makes sense, bro. I'm not sure about this task file. The task add file is, can we go there? No, source, scheduler. So I think, I might just check that should fail, because I added an EDI, but I'm not popping it in, so they were like error, so that's probably good, because I need to remember once I go back, and if we go to scheduler, task add file, this is like a bit hacky as this comment says, but it should return a file descriptor on the task. So, what am I thinking here? I think we don't actually this one. We don't actually want to like create the task. What we want to do is, we kind of just want to malloc word size times 2. So we're kind of doing similar to this. Because when we go buff scheduler, when we create a new task, actually no, it is in source lib unistd. When we do the fork, we do like a weird test thing, but that's alright. When we copy the stem frac, no, it must be in this new task. So buff scheduler, new task does this do a thing that I want it to do. Set up that task copy task copy. So what I wanted to do is basically see whether if we create so if we go back to term, if we just do this, we don't want to do a pipe. So what I think I want to do here is move EDI to EAX, and we don't care about that, and this will be EDI and EDI, and we don't care about that, and that's alright. And this, I think we want to go down to the child and set that to be our standard out on there, and so that's that. Yeah, I don't think we want a pipe here. I wrote a comment saying we keep on doing wrong here. Where we go? Sure, that's good enough. Yeah, so I said I wanted 2 pipes, but I don't think I actually want a pipe for the standard out. Because where's the pipe going? It's going to be like the end of the journey. It's just going to put seeds in the term. Yep, so we just set it to EDI, and so I think we do that and set this to EDI. Yeah. So now the term iOS object is now EDI, and do we need to do any cleanup in the parent of that EDI? ESI is a pipe for STD in forwarding. EDI is the STD out of the term. So I don't think we want to close anything there. Yeah, we want to keep EDI there. That's fine. And here we want to set the EDI to be our standard out and close that in the child. I think that should be fine because it won't like remove the stream. And I'll just double check. Yeah, that takes a file descriptor. Yeah, it basically just removes that from that. Some like weird knocking noises somewhere. So STB out should be the term STD out. And yeah, that's good. I might just do that. And move that comment there. Let's give that a whirl. Now this should fail because down here we are not going to put EDI. I think that's probably safe to do now. And let's run it. It's complaining there because we took out the I might buff kernel. I might keep this in. Progress has not been made. Yeah, and how long? We've gone an hour, and I don't know. I feel like some progress has been made in the sense that I might just clean up stuff that we don't care about. The fork might still have some issues. The pipe might still have some issues, but I think we have tidied up some of the kind of to-dos that I set here. And if we kind of step through this, which I'll probably do in another episode, just because don't want to like do too much and not get anywhere, because that's not too exciting. Yeah, so I'll maybe commit this up, and we've got like the broken commit. And yeah, I think I might like branch off so main still stays sane. Yeah, and then we've done like a bunch of commenting and setting up stuff here, and we've probably got a clear idea on what should be happening. So when we do some more debugging, we should be able to track their objects and be like, no, that's not right. And one thing I wonder, which I might just to do, should this wait until the... Nah, it should be right because it'll be reading from the pipe, and the pipe isn't full. Yeah, I was thinking like, does it need to wait until the kernel has, well, the parent has like done these three? But nah, that should be alright. So yeah, I think that's a good point to stop there. And so what I might do is look at that. Yeah, so that commit is yeah. What a foolish bastard you. Yeah, so what I might do is get branch. Well, actually, check out might be and what we want to call this term for fixes, and we'll see what we have. So we've got some comments, we've got this, we've kind of done that. Some more comments. Now, what do we do here? Yeah, we change. Yeah, so in essence, we kind of just put the standard out of the term, like, and that's alright. Sure, like that. I'll just do it all, and I might just do work in progress. And the STD add to term into new. The still even is not working as expected, but progress was made in the understanding of what is happening. Yeah, so I think that can be good, and I'll push this. Git push set upstream origin. So like, if people want to look at it, they can. I need to do personal. That's the one. Yeah, we'll push that. Gosh, what was happening with that? Cool. And what I might do is go back to here and revert that. Well, actually just reset that. Hard. And so this is still in the working spot, and it's got like a couple of things that I added. I started testing memory.inc because I think there was a bug there, I can't remember. But yeah, I guess we can push that. I probably don't need a force replace on main. In fact, that's probably not a great thing, but it's just a fast forward, so that's alright. Cool, yeah, so that's that. So this is broken, but if we look at source drivers includes these two. Oh yeah, it's like weird. Yeah, that doesn't work. And what I might do is just kind test and maybe move the skip test to out here. Good to have the tidy up and maybe move that bicep or like what's it looking like? Cat bicep. Yeah, I'll just remove that. I can recreate that sort of thing again. And yeah, I think that's good. My internet's died at some point. The Wi-Fi's been playing up, I'm not sure why. But anyway, the video should still make it. There, it's just come back. Secret garden. Oh yeah, you can't actually see down the bottom there. I've made it so you can't see that, I think. But yeah, thank you for watching, and if you enjoyed this, let me know somehow.